Okay, so this is your video for 8.2. We are beginning trig, which trig will be the rest of this chapter, and then it will come back with a vengeance in pre-cal. Pre-cal is basically half an extension from algebra and half trig. So this is a concept you really need to have a firm understanding of. Okay, so often in trig, the side across, oh, by the way, I increase the font size and I'm not zooming in as much on the camera. I'm trying to reduce the fuzziness factor. So let me know how it works on Monday. Okay, so the side across from the angle is named with the same lowercase letter. So this is angle A, this is side A, angle C, side C. This helps remind us that angles go with the side that they're across from. Okay, so trig is based on these three ratios, and all they are is ratios. And you have this on your vocab chart, but here it is again. So these are the three basic ones. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So these are three ratios that you're going to have to know. Now, if you spell that all out, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We can remember it by using the made-up word SOHCAHTOA. So SOHCAHTOA, if you remember that, then you'll always remember your your trig functions. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Okay, so we're going to practice these here. So example 1, write each trig ratio as a fraction and as a decimal rounded to the nearest hundredth. Okay, so sine of A. So we go to angle A first. We know that sine is opposite over hypotenuse. So we say, okay, opposite from A is 3. Adjacent. Now we learned the word adjacent in chapter 1. Adjacent means next to. So you have two choices for who it's next to. It's next to the 4 and it's next to the 5. But the very first thing you should do when you start a problem is label this as the hypotenuse so you don't ever confuse him with adjacent. So this is not adjacent, it's the hypotenuse. So the 4 is the guy that's adjacent. So the sine of A is 3/4. So that would be 0.75. Cosine of A. So cosine stands for adjacent over hypotenuse. So we already discussed, according to angle A, 4 is adjacent and 5 would be the hypotenuse. So that's 0.8. Tangent stands for opposite over adjacent. So now this time we're going to B. So you have to change your perspective. Now we're talking about B. So opposite of B is actually 4. And adjacent from B, not 5, 5's still the hypotenuse, adjacent would be 3. So 4 divided by 3 is 1.33. Okay, so you really need to be comfortable working with these ratios, who's opposite, who's adjacent, and who's the hypotenuse. Okay. Alright, so now we are going to use special right triangles to find the tangent of 30 degrees. So here I've already labeled my special right triangle. 30, 60, 90. Across from 30 goes x. Across from 60 goes x on the square root of 3. Across from 90 goes 2x. Okay, so tangent we just discovered is opposite over adjacent. Ooh. So opposite of 30 is x. Adjacent from 30, not 2x because he's the hypotenuse, so it would be x over the square root of 3. Now, when you do these special right triangle ones, they're all have an x in them. So no matter which trig function you get, it's going to be some form of x over some form of x. So the x's are always going to cancel out and leave you with just numbers. So in this case, this leaves me with 1 divided by the square root of 3. But you know we're not allowed to leave the square root on the bottom, so we have to multiply. This is called rationalizing. So 1 times the square root of 3 is the square root of 3. Square root of 3 times itself is 3. So the tangent of 30 degrees is square root of 3 over 3. We get that from using our special rights. I could do this with all of them. What's the sine of 45? What is the cosine of 60? I can do this with all of them, and you will have to. Okay, for ones that are not special right triangles, we can use our calculator to tell us the answers if you're on a calculator part of the test. But what you need to know is that your calculator, there's two forms. Just like you can measure in inches or you can measure in centimeters, you'd be measuring the same length, but you would get two different answers. There are two different measurements for angles: degrees, which we know of, and radians, which you will learn about in pre-cal. So for now, since we're only concerned with degrees, we need to make sure we're on the same page with our calculator. Now, unfortunately, the normal mode for calculator is radians. So if you don't change it, you're going to have all your answers be wrong and you'll never know it. You have to do this every time you get a calculator, because if the batteries die and I change the batteries, it goes back to radians and you would have no idea because you weren't the one who missed the battery. So how you do that is you hit the mode button, and then the third line, I know that's little, the third line is the one that says radians or degrees, and we want degree to be highlighted. So mine already is, but you just arrow down and over and press enter, and then it's in degrees. Now we'll do that again tomorrow when you actually have a calculator. Okay, so this question is just super simple. Once we're set in degrees, all you have to do is type this in your calculator. So here's sine, cosine, and tangent buttons. They're right above, 2 rows above 7, 8, 9. So it says, what's the cosine of 51? So I type it in, and it says round to the nearest hundredth, so I get 0.63. Then it says, what's the sine of 29? So I type it in, 0.48. What is the tangent of 78? And I get 4.71. Now, here's something to help you kind of keep this straight. Sine and cosine of an acute angle, which ours are going to be acute, because for right now, until we get to the end of the chapter, we're only doing this with right triangles. So for now, everything, all your sines and cosines have to be a positive number, and they have to be less than 1, just like 0.63 and 0.48. Tangents can be any positive number. That's why we saw 4.78. Okay, so sine and cosine, positive, less than 1. Tangent just has to be positive. Okay, so now example 4. This is where we get into the meat of this. We are going to find side lengths of triangles by using trig now. So here we are going to find PQ. So I'm going to call that X. You could just call it PQ. It doesn't matter. We start with what our angle is, and we decide which two pieces, what piece do we have and what piece do we need. So according to 35, 7.3 is the opposite side, and 35 is the adjacent side. So I need to use the trig function that uses opposite and adjacent. So I am going to use tangent. The degree always goes next to the trig ratio. So tangent of 35 equals opposite is 7.3, adjacent is x. Now you're just going to solve for x, because remember, tangent of 35 is just some number. So we're just going to solve. Now, the interesting thing about algebra, and I don't know if you've noticed this before, is if your variable is in the bottom, all you have to do is switch places and divide. So I'm going to rewrite this. X is going to be over here, and tangent of 35 is going to be on the bottom. Then I just tappy this in my calculator. 7.3 divided by tangent of 35. Press enter. And I have my answer, 10.43 inches. Okay, let's try some more, because I know that's different. Okay, here's this one. Find YZ. Okay, so again, we're looking from 49. I'm not going to use X because that's already in the problem. I'm going to call this M. So, according to 49, 3.7 is the opposite side. And M, or YZ, what I'm looking for is the hypotenuse. So if I am needing to use opposite and hypotenuse, then that would be the sine function. So sine, angle goes next, equals opposite, 3.7, over the hypotenuse. Well, again, the variable is on the bottom. So again, I'm just going to switch and divide. M is equal to 3.7 over the sine of 49. .9. 4.9. Now that's a reasonable answer because the hypotenuse should be longer. So this side's 3.7, this side has to be longer. So 4.9 is a good one. Okay, pause and try to do C. Okay, so here's this one. I'm looking for the adjacent side. I have the hypotenuse. So I set up my equation cosine of 66 equals x over 5.7. Now this time the variable is on the top, so I just use regular algebra to solve. If they divided by 5.7 in the problem, then I need to multiply by 5.7 here and here to get it off. So all I have to do is type in my calculator 5.7 times the cosine of 66, and then I get 2.32 centimeters. And this seems like a reasonable answer because it needs to be smaller than the hypotenuse, so 2.32 seems to work. Okay, so a word problem, the only difference is we're going to need to draw our picture as we go. So the contractor is building a wheelchair ramp for a doorway that is 1.6 feet above the ground. So this is going to be 1.6 feet. To meet with ADA guidelines, the ramp will make an angle of 4.8 degrees with the ground. So this is the ramp right here. So it's meeting the ground here. So this is your 4.8 degrees. This is your 90 degrees. To the nearest hundredth of a foot, what is the horizontal distance covered by the ramp? So the horizontal distance would be obviously this guy right here. Whoops, sorry. Okay, so let's look. According to the 4.8, this side is opposite and this is adjacent. So if I want to use opposite and adjacent, I would say tangent of 4.8 equals opposite over adjacent. The variable is on the bottom, so I am going to switch and divide. X is equal to 1.6 divided by tangent of 4.8. 1.6 divided by tangent of 4.8. And the ramp is going to cover, to the nearest hundredth, 19.05 feet. Oh, sorry. 19.05 feet. See you tomorrow.